Welcome to the eLab Innovation Podcast, the podcast on e-mobility for research and industry. My name is Simon Voss. I'm the Managing Director of eLab of RWTH Aachen, and today I'm excited to welcome Bryan Ng, CEO of camLine, to the eLab Innovation Podcast. Together, we want to talk about the topic of digital continuity and what it means for EV manufacturing and especially for battery production. I'm happy to welcome Bryan here at eLab.
Important thing is that if you have this information, data is become powerful enough to decide how you can have one grid of networks that store all this data so that you can really share. And if there's a new company come in with the great ideas of design, they also see how long that their product used in the markets, how many times it's capable to recharge and so on. These all are real information.
All right, Bryan.
Hi.
So thank you for coming here to eLab and welcome to the eLab Innovation Podcast. I'm looking forward to the conversation.
Yeah, same as me here as well. Thanks for invitations. Yeah.
Great. So today's topic, digital continuity. Before we reveal what it's really about, it's about manufacturing, as the subtitle reveals. I wanted to ask you another question, a personal one.
Okay.
How you entered the field of e-mobility, of battery production, and where the whole journey for you started. Well, maybe you can talk a little bit about your past, about your personal path.
Okay, so maybe just to share, my background has been in the interest of electronics and electrical engineering.
Okay.
Started with that in my bachelor's times, studying in UK. So we actually a couple of friends doing
the
thesis.
Where in UK?
North of London.
Okay, so London.
Hertfordshire.
Okay.
Yeah, the University of Hertfordshire.
Okay.
So there are a couple of friends that we come together to write a thesis, and one of them is really car enthusiast, and he even tests car. Yeah. So then we came to the idea. Okay, we like electronics, so why don't we write a papers about EV at that time? So that was really almost 30 years back. Yeah.
Okay.
Right. At that times we are already crazy thinking about can every electrical wheel itself has a direct DC motor apply,
So 4 motors in the wheels?
4 motors in each. Each wheel has a motor, so you have 4 motors, and really comes to inspiring how drifting will work. Different speed, different differential speed.
Yeah, looking at all the fun stuff.
and if you really drift a car, what does it mean? Left side have to slower speed, or right side you have to increase the turn ratios, for example. And
track control is really
So learning about all these motors, electrifications in the cars. At that point, it's still a theory, so nobody really built a car. But we already really have.
When you say at that time, when was that?
In terms of years, I think it's 1998, 97.
Wow. Okay.
Yeah, that's quite long
almost
ago.
25 years ago.
Yeah. So when we start, we have a lot of discussions with friends and talk about, we should write a papers, when we do a bachelor's degrees and
build an EV startup next year and like dreams that you have as a student.
Dreams, yeah. But at that point, we also realized, I would say the difficulty to start up such a dream is always like, do you have a real industrial experience, and get it your hands really knowing what is needed to develop such a dreams, right? So, and from that point, I continue with my master's, doing other electronics learning and studying down there. But eventually, when it comes to a practical world, I was thinking, what should I do as my career? Of course, I went into semiconductors, knowing all this semiconductor process. I'm really excited to learn about manufacturing.
So after your studies, I think you looked at, or considered doing a PhD, but then you decided for industry, right?
Yeah, that's right.
Okay.
So going into PhD is always a big commitment.
And
you're doing theory, even more theory stuff,
I can tell you.
And from that point, so I say, okay, let's do a turning. I really like to run the business and really get hands on making real success in building up let's say profitable companies, right? And that's how I came back to Asia and start to look into. There's a lot of manufacturing.
So from England, you went back to China then?
No,
Or
went back to Singapore.
Singapore.
Yeah,
Okay.
yeah. So started off to look at a lot of manufacturing around in Southeast Asia, and that's kind of interesting to go in to learn about what they actually manufactured and how they produce it.
Yes.
And that's really an interesting journey to start off. And by that time, I already discovered camLine, which is now I'm the CEO of camLine.
Yes.
Starting as a resellers of the software solutions where we don't have to invest big capitals, where like buying a capital equipment, like what you do in eLab here, seeing your journeys of building the labs where you involve a lot of hardwares and capital investments. So when I start the software business, it's really kind of luck. We ventures into manufacturing areas. That's what I also like. And we also found camLines, myself found camLines that are doing software just for manufacturing. And
So that was when, so you left school
2001 then.
2001, and a couple of years later, when you went to the software, decided you want to take the business route, and then you went into SMD first, and then
I started with semiconductor first, so making chips, how to make chips, how the process of in designing chips. So part of my early study.
SMD, surface-mounted devices. So
that is the component at the end of a semiconductor is a component, could be surface mount, could be a device that, let's say, much bigger size like a CPU process or GPU process and so on. And finally, you have to mount it to a PCB board, and finally gets into real applications.
For everyone who is not familiar with those it's a printed circuit board.
Yeah,
right?
printed
so
circuit
those
boards.
green
red
epoxy boards that you mount
in
the electronics on.
Right. So if you think about e-mobilities, and you would have a lot of those controller boards that they build it to control the cars, to control the movements, the sensors that even on the tire pressure sensors is also another small little miniatures, let's say, devices that produced in the factory. So it's very fascinating to see that how they make it. And at the same time, when the more customers that I engage at that moment, it's really a very good learning journey to understand how can we really capture those data, use those data. It controls the manufacturing, how the machines should have behaved, all those.
For the chip manufacturing.
Just for the making chips alone. To make one chips, it probably takes about 60 days to 100 days, depending on what kind of chips that you are making.
You mean the development part of it?
Yeah, the whole, not development, mass production, just doing a mass production.
So from the initial requirement where you say, okay, I want to manufacture this chip. Let's say there is a customer who says, hey, I have this design. Can you manufacture that? So it's like
that is even more longer. That could take 6 months to 9 months.
Okay, good. I was
so
wondering.
From a design stage, you have to really prototypes in the language of what we call VHDL, like a descriptive language for the chipset to behave. And then finally, you have to optimize, miniatures it, and then you come to a form of factors that you can really what you want. First is function. Second is you want to miniaturize it so that you have a form that you can
put it into a microphone case like this, or in a
or your iPhones, like that, the phones that you have. They are getting smaller. One hand, on the other hand, is also more complex because you have many players within different, let's say, companies. One may be producing like a
higher processing power, so the thermals become more important because there's more energy flowing through them.
And even for EVs, you have a lot of control systems. So in the past, probably 20 years ago, we only had 10% of the electronic parts, but the rest are all mechanicals or metal parts.
And that's
but
changing
now. Changing a lot, right?
It's a rolling computer.
You can say it's a very expensive rolling computer.
It is, yeah.
Yeah.
So maybe from that point, so then you entered camLine, and somewhere in 2000.
Yeah, 2001.
Okay.
So it starts and
so
from
then
there.
We're elaborate on the chip industry and the semiconductors because you made a lot
from
of
the ground.
From the ground, like many experiences in that field.
Yeah.
And in our preliminary discussion, I think you drew many parallels between that industry that was evolving more back then, right? now the smartphones and everything, like the whole industry has matured a lot due to the customer needs for slim, high performing smartphones, for example, as one use case, one product. And then you now entered the field of over the years into the field of EV manufacturing, and more specifically, perhaps we could touch on that in a minute, on battery manufacturing and the supervision, so to speak, by means of digital tools, to really understand how every process and every unit along the value chain connects to another, right? That's
Correct.
kind of
if you think of EV now, the biggest I would say the components beside the chassis of the car body is really the batteries. Everything else is getting more optimized, miniaturized, or even efficient.
It's more an engineering topic, I think, on that end. And in terms of the component that you're talking about, batteries, that's really where kind of everyone is still struggling to find the optimal design, to find the cost optimal solution that drives the cost down, and etc. Right?
Yeah, because you're no longer using oil, so that means there's another form that you need to store energy, and the biggest challenge will be how much you can store and how fast you can store it, right? So in the past, we pour water, immediately be done. Now you have to really think about digitizations, because battery also, you have to take the safety in considerations. You need to control it. You need to really know when is the right time to pull the full power to charge it or reduce them. Avoid that safety problems.
Before we dive into that, and also with the example of the battery, let's have two perspectives on that. One is looking at what does digital continuity really mean. One perspective for the whole EV, for the electromobility or the electric vehicle in that case. And then we look at one component like the battery and the manufacturing of it later, because there the value you bring to the table, I think, really becomes apparent. And what is so special about also this word digital continuity, to understand it and to develop it further. So let's look at it from a holistic point of view. So what is digital continuity? What does this word comprise of in terms of the EV?
So let's say if you look at the word digital continuity, is the whole target here is to make sure that we don't have silos of data, that we couldn't bring it to the next stage along the process.
Of the product or of the manufacturing?
It can be the product, it can be the manufacturing. If you look at EV cars, so let's say the EV car is fully on the road running now. So what information that is carrying now? Does it carry all his life cycles information from the day that it was born, the test data that before the car is delivered to the customers, and then now that data, it's already some formations of collections of data. Now goes to it's daily use. How the data connected? Like how many times it has been recharged. When you look back, the data itself is not siloed. It's not just like only the charging cycle time at that very moment.
It's not perfectly compartmentalized and categorized.
And well structures in the ways that you can see that, okay, I have that digital twins of the product. What is data collected along the way until it reaches the consumer hands, that use it daily, how many times it has been charged, until you get to recycle. And the recycle, let's say someone to recycle the whole car, they were able to get to know this is the battery came from where, when it was manufactured, how many times it has been recharged, and whether there's any back components within the let's say the vehicle's life cycles.
Okay, so they're like, let's put it in three categories. One is the whole process until the product is finished, so the manufacturing part of it. Then we have the usage as the second phase, and then what you touched on would be the recycling. And
correct.
I think the picture you're painting is you need a good understanding of the whole value chain later on, because I mean the industry is not there yet, and I would really seriously wish that it would be, that we think things from the design. We saw it back in the machine shop, right?
Correct.
The battery packs that are actually manufactured right now, that they are from a design perspective already taking this whole closed loop aspect into consideration, and really make it a key criteria for their design decisions. It's not the case right now. I can tell that from our research, and I think you offer one key for getting a little bit closer to realizing that by means of the tools that you provide. Is that correct, kind of, to outline?
More important thing is that if you have this information, data has become powerful enough to decide. First thing is, should I recycle? Second thing is it the lifespan is already end of the life, or it can be like continue to another, maybe the same chassis but different body design, and goes on for a different usage. So again, data,
so understanding the actual status,
actual status,
state of health, for example, of a battery cell. That's
correct,
what you mean, right?
Right. Yes.
To make valid decisions that are actually grounded on knowledge, not just on guessing.
Correct. Or even just based on some simple track records, like the year of manufacturing. Then you decided, okay, it's already 10 years, we should go and recycle. But in fact, that there's a lot of data that you could already carry on as a digital life of that product, continuing into real usage, continuing into until it recycles. So when you recycle a product, if you know his previous life, then you will also know that, okay, would it be a value for me to really spend the energies to recycle it, or it has to do a different treatment to ensure that there's proper, I would say, end of life of it. So if you look at that aspect, it's like an industry, right? So how that digital continuity, so that the data that we capture right at the manufacturing goes into mass production, goes into real life usage, and then finally is it let's say carry on to recycles. So battery is always a key.
Is it one entity that is then controlling this pool of data, or how would you as a company, to just understand also your business model? So you're providing tools that allow the capturing and the
today I would say there's no entity or even a company like us able to provide that. Like open platforms where everybody can contribute to share that data, and again,
like a blockchain of
so not even just blockchain, but how you can have one grid of networks that store all this data, so that you can really share. And if there's a new company come in with the great ideas of design, they also see how long that their product used in the markets, how many times it's capable to recharge and so on. These all are real informations, and again, if you have a platform that is able to have all this data, then you can come back to the design, like you say, come back to the design, maybe where are the improvements, so that the real prolonged life of the product is really improved over the time. So nowadays we have battery life that is, let's say a laptop is only 3 years. After that you really have to change it. But nobody really knows the fact that why some of the laptop can last for 4 years, some of them last for 3 years. All this data is, it's captured somewhere, but it's not going back to...
And it would be good to know.
Yeah, it's going back. If we go back to the manufacturing, let's say how they can improve the manufacturing, the design of the battery itself, then comes to a level prolonging the lifespan of the actual product itself.
So you're providing tools on allowing that capturing and that...
So camLine is really software for manufacturing. So let's say if we come back to ground. Don't talk about the big pictures of the industry. Let's say we just
we make it a specific use case now on what you provide, right? So that's the big picture on how this
digital continuity
building brick that we will discuss in a second, how this building brick fits into the big picture, right? We have those three phases. We have manufacturing, we have usage, and we have recycling. I mean, recycling is a part kind of manufacturing as well.
Yes.
So and we want to have transparency of the whole value chain in terms of data.
Yeah.
So and then how that is done during the life cycle. For example, I had a very interesting conversation with Dr. Kai-Philipp Kairies from the company Acure last week, where we talked about exactly that, not the manufacturing, but the usage and how they monitor the usage and how they deal with the data.
Correct. Yeah.
So that is that building brick. And now we come to your building brick, saying, okay, what are the solutions that we can use, digital solutions, digital continuity along the manufacturing chain, right? And there we enter your discipline. And let's do this with the example of the battery manufacturing, I think, because that's such a critical component. And Do we want to start with where do we want to start with the raw materials?
Let's say
Or
your the incoming materials that you buy, whether
the
you,
powders.
the
of the
powders,
battery?
whether you get
Okay.
it from a recycled source or it's a mining source, doesn't matter. The important thing is now when the start of the manufacturing, let's say if you look at battery, is creating the let's say solvents, mixtures that you are intended to, with the content that you want. So that's kind of the beginning of the digital life of what you manufacturing. So if you continue from sourcing the right powders, knowing where it come from, knowing the integrities behind, the real values, not values, but the material integrities itself, and then all this has been coming from either recycling plant or mining. They already have that data, for example, coming from their labs, testing for every batch of powders that they have on hand, and the batches of powder that ship to manufacturing. So that already started with the digital data life already. So then from that point of view, actually, you can automate with the suppliers to connect those data, like from one corporation sending those digital data about this batch that I sold to you, then providing this electronic information that you can continue to, based on that, for your manufacturing process, right, to use that data as well.
May I ask a practical question? Is that format of the data that is provided there, the information, is that in a standardized, like structured way, or is it customer specific?
Well, I would say, let's say for example, specialty chemicals and gases, there are structure formats, and if you are the big players to that supplier, usually you can determine what I want. I'm buying something from you, I can say these are the content I expect that you can provide to me. Okay. And then those content has to be like, for example, for every batches that they bought, right? That's where it can be very custom. Or there's also, in semiconductor, we also have a standard, where let's say you buy sources of gas, there's a standard format that every supplier is providing. Yes. And if you're the big player, you can ask for more. If you are a small player, of course, you take the standard one.
Yeah, you can shape the industry.
Yeah. Then
so that's for semiconductors. And then now drawing the parallel to the battery field, which is kind of emerging still in terms of standardization. Do you see that it's coming? I mean, it's a very relevant point, right?
Correct. So if you think of it, we are in a world that we want to save Gaia. When we also want to know where are we doing the right source integrity, whether it came from the legit mining source or proper recycling process. And then whatever is coming to the factory, of course, you want to have the first-hand knowledge. What am I receiving? Yes. And do a proper decisions of saying, okay, I have a batch that come in with the problems, or I have a good batch that comes in maybe to start it, use it for maybe high-grade end product I'm expecting. If you do a battery pack, for example, for high-end customers, you would say, let's cherry pick some batches which are high quality.
Of course.
So to deliver what is expected.
Grade A batteries, got it, So, and even if it's not like out of range material, you still need to adjust to some extent because nothing is the same. There are always deviations.
Correct. If you don't have this collaboration with the suppliers, where they are specialists on this, they mine, they provide those powders. They even have lab tools that is better than you are. But if you look at it, if you don't have that collaboration, it will end up like you create your own lab to do all this incoming validations.
Those are also costs, right?
Yes.
The more you have to double check, like every double check is one check too much in that regard. If you do one proper measurement, you would be good, right?
Or even that before the material fall out from that chain of the manufacturing and corrupted or even polluted the next chain, so-called, then there's a lot of energy wasted to contain the issues, right? A lot of manpowers and also control in place to prevent that.
Downstream costs that emerge.
Correct. Then if you look at it, if you save the cost of incoming check, you could already collaborate with your supplier to spend more, right? Even buying more from the supplier itself.
And because I know you're just coming from a big business trip, you see this talking to many customers. Do you see that as a current issue that is discussed a lot?
Well, at this point of time, people want to have those data,
Yeah.
But the collaborations between the source suppliers and also their own manufacturing is not really, let's say, such a good sharing.
Yeah. So it's a trust thing and it's a standardization thing, right?
All right, it's competitions, right? I'm producing something using your powder, but if I produce it at the end, the result wasn't good. I couldn't give you back this data so that you would understood what happened. And then the other part of it, there are suppliers who are afraid that this data start to share with competitors. Yeah,
of course.
Because you're not going to do single source, you're going to do multi-source, right?
Yes.
So that's also another level of trust. At the a newborn industry, evolved industry, they always have this fear of, hey, should I give you more data at the end? Is it going to be like double-edged source come back to me, hurt me because you leak the data to your competitors and so on? So these kind of things, I think one important aspect is if you always innovating, you are not afraid of competitions. You will always challenge the competition, right? So if you can convince,
if you take time to your advantage, right? If you're ahead of the
whether you're ahead of the curve, understanding now, okay, I have a batch of materials problems, then you find out that that's what really the problem is, and you immediately fix it. And that kind of collaboration and trust should build between supplier and manufacturer, because if you buy the product, and now it's a main ingredient in your manufacturing process, then you want to make sure that you have a good collaboration because that's the main ingredient. It's not like common ingredient like waters or electricity where you don't really pay attention to.
Yes, understand.
Yeah, that's how I see the digital life start. Yeah, from the materials that you're buying. If you continue that journey, so now the material gets into productions, right? Where the mixers, the right ratio of mixers, what you are mixing. This is, again, your IP. You will not really tell your supplier how you mix it. But you are using those
specific
materials.
Machine parameters.
Yeah. And then those are your own cooking recipes that you not simply share it out. Yeah. But look at that. You want to carry that digital content to the next step of mixing. Then if you collect all the sensors data from the mixer, the spin speeds, the viscosities that you did on the lab, and then finally you figure out, hey, actually we already have that kind of, let's say, powder form where the humidity is not dry enough, and then causes another problems in mixture.
Yeah, so from the kind of the legal boundary that we were overcoming, procuring the material, getting the information in form of data.
Yeah.
What do we actually receive? Right, there thing like standardization is a point, and like contracts that have to be set up to build the trust on actually knowing, okay, what do you deliver me, because I need to know it for parameterizing my process. And now we enter kind of the technical domain, right, where you connect one machine after the other and solve the engineering puzzle on how to fit everything together, right, and make one streamlined production out of it. So from the mixing, now we come, or from the powder receiving, we come to the mixing, and now,
you
please go ahead.
A solvents, and then you never know that should I now go to the lab and test it and find out that the mix is ready to go, for rolling process, calendaring. But that point decisions, you also sometimes you need to, let's say, link the data together. That's where the digital continuity comes, right? If you never link those data to have that continuity, which supplier batch I'm using now, which how many percent that I'm using, and then mixing it with other batches, what kind of effect that came out, and then when you drill back from the lab result, you could see that okay, it could be like one of the supplier batch with that content of data they provide to us, we discover the problem, the root cause of it.
So it's a lot of math involved, and as far as I understand you, in terms of finding correlations, and showing the operator, the manager of the plant, hey, there is a correlation. Tell me if it's also a causation.
Correct.
Right. That's kind of the what you provide.
Yeah, exactly. We have a software that is cornerstones, and we also write papers on this together about finding the right design of experiments or even correlations of the parameters together, and you get an instant engineering decisions rather than a gut feeling. and a lot of times when operation has a problems, discover the quality of the process coming out is no good, they always will ask, is it the operator picked the wrong recipe? Did the operator do the right thing? But this is more like we are looking at, immediately we are blaming manufacturing. But there are another aspect that you have to look at is really, do you have the data, even knowing how was the material was mixed? How was the speed of the spinning?
Full transparency.
Full transparency. Not just looking at operationally something goes wrong, but looking at really having the data collected from the machine, collected from the supplier itself, having the concrete judgments. Yeah, we don't have a problems on the process. Okay, this is a human error. Next time we should have a SOP not to repeat. But finally, if you found out it's a supplier issue, you can immediately trigger your supplier. Hey, do you have more batches that's similar problems or not? So that I do not have such disruptions in my manufacturing floor, right? So that you can go back and say that these are the batches I should stop. And then you can, as a supplier, you can figure out how to solve that problem. But on the other hand, I can use other batches to continue.
Yeah. You're really drawing the complex cloud on how everything is connected or can be connected. And I think one thing is to connect everything. It's only half the game, because you just see that it's really complex, right? That's complexity, and the value you now describe that you can bring to the table if you have the right engineering behind it in form of the right software tools that you have developed and that you provide. You can highlight the links in this complexity cloud that actually can say, hey, if you really tie these together and if you look at them closely, you can create more value. You can streamline your process. You immediately know, no, it was not a fault of the operator or a fault of the plant manager or the engineer that set the parameters for that or that recipe. It was a supply chain issue, etc., right? So
exactly.
I think the value to summarize it from my perspective is you let the whole operation mature.
Yes, not just mature, but also to let's say standardization point of view. Right?
Yeah, that's what I understand as maturing in that regard.
Yeah, we get all the correct data in hands, and now in battery manufacturing, if you look at it, there's a lot of row-to-row process, continuous monitoring, continuous let's say scanning on the surface to
especially
find
during electrode
defects,
manufacturing.
Electrode manufacturing here. So that comes to a point where you have a lot of data that you collected. Finally, how you link those data, like this row get into a pack or get into a form, and then you have the traceability to find back this what came from which row, this came from which mix, this came from which supplier batches, and then finally
so which
you
particle and result or found its way into which battery cell on which sheet within the battery cell, right? Kind of to that granularity.
If you go to that level of, let's say, level of traceability, then it becomes critical that you have this digital twin of it, that you can link all this data. You have the digital collections of those data that you are relating them. Not just like a silo, only, let's say, this tool, this process, that's it. You never really link it back to the previous. Then you always don't have this visibility and help you in decisions.
Okay. So, Bryan, I have two questions on that. One is a very practical one, again, out of your experience from current industry. What's the status in industry right now? When you look at all the gigafactories that are built or that are going to be built, I mean, right now is the planning phase, right? We also here get a lot of calls like, hey, what do you need for this manufacturing step on measurement equipment, on et cetera. So the discussions are rolling right now all over the globe, I think, and also especially in Europe because there are so many plants built right now. From your perspective, so I have kind of the research view, kind of on the edge to industry, but I think you're right in industry and see what is discussed right now. Do you see the view that we described here right now, getting full transparency, striving in the direction of standardization, up and downstream of the process? Is that the standard right now that is discussed, or are there some who really take this seriously and see the value in it, and some who do it in a more old-fashioned way, saying, it's a nice tool, but the overhead on this whole digital thing is too much. I just calibrate my process to a very narrow tolerance band and hope that it runs well.
Well, in
So how do you see that right now?
I see it in this way, right? For example, battery being not a commodity components in all OEM. They all build their own batteries and design their own battery packs and even the chassis to host that for EV. And automotive industry is very strict with quality and in fact most of the OEM automotive is driving for 0 defects. So you should
Like
not
Six
deliver.
Sigma
You should not deliver a defective goods to my end of the product that resulted. I have a lot of product that came out with problems. Yeah, so the quality standard is pretty critical, and to have that drive for improvements on qualities and achieve 0 defects, you need those data. You definitely a lot of big players with gigafabs now, they want to have that ability to collect those data and able to trace them. Yeah,
Okay,
identify them and trace them. And this, I would say, everybody struggles in the way that there's a lot of data to be collected because nobody knows when they need it. But as a manufacturing point of view, this become a critical because the industry that just started is not like other industry like semiconductor. All this they have already established more than 30 years on how to automate, how to capture data, how to improve.
Yeah, the things are just starting off, and everyone is.
So if you scale it from the lab, very straightforward. So, like what you have here, maybe you're collecting a smaller batch, maybe 1,000 batches per month. But if you have volume manufacturing, you are talking about million batches per day. It could happen at millions batches that you have to track and trace per days. And
not done by hand.
Definitely you will not want to write it down everywhere. You want to look at automations, you want to look at collaborations with your equipment suppliers, your incoming material suppliers to get everybody on the same understanding of standardizing, automating and collecting valuable information out to make good manufacturing process. And at the end don't generate more waste. If you imagine that you have a batch that is not good, you have to scrap them or you have to redo. That's a lot of ways that we are trying to avoid, right? In fact, we come up with EV is also to
predictive quality, I think is their buzzword.
Predictive quality, or see it before that it really happens, or stop it so that it doesn't continuing hurting us, wasted times, wasted materials, wasted a lot of energy in recovering it. So this kind of monitoring and ability to, let's say, automize and bring the new standards into manufacturing ground, collecting those informations and make it really help the engineer. So no engineer like to be a secretary, like writing all recording.
Of course.
They want to use their brilliant minds to analyze data to really contribute to make the process better or even productive. Make it
so they want to be the choreographs. Is that a word? on like building the symphony for manufacturing, that everything plays with another. And I think you're providing one tool allowing to see the big picture, as I said, that enables that. Because that leads me to my second question. So as to sum up your answer on that, I think what I took from it, there's really no way around it. Right, I think that's like if you want to build. So for everyone who wants to build EVs, who wants to go into better manufacturing, just use those tools, 21st century tools that are out there, in order to streamline your manufacturing. Right,
correct.
I think that's kind of the key message. Linking to another very important topic, which is the whole point on safety. I think one critical argument, also customers always say, when I have discussions with my family members or friends, is always the question, the first question is always, how far do I get with the EV? And then say, I cannot get so far, and that's why I'm hesitant on buying it. Right? I think that the second one is, are EVs really environmentally friendly? There's cobalt in it, etc. And then at latest, the third question comes, but they can catch fire, right? So that's kind of the third one. And then
will it heat up my butt before it really goes on?
Yeah, exactly. And then I'm always tempted to show them statistics on, look at the statistics on how many commercial or combustion engine vehicles catch fire on the global picture, and then how many EVs. Not in total numbers, but in relative numbers, right? And then the picture is clear. But nevertheless, it's in the media. Everyone's looking at it when an EV catches fire, and it will continue in the future, of course.
Spotlight,
And I mean, yeah, it's a spotlight, and of course it's important. I don't want to downplay it here, but because it's also so heavily discussed, there must be solutions, also from an OEM perspective, in order to make sure that they provide a product that is safe.
Yeah.
And in case something happens, that they can say, hey, we did our job well, we did our quality control, but we know what was the reason. And I think that also plays in the direction that you argued, where you say we need full transparency, and not just out of technological or technical reason to optimize the manufacturing, to optimize the cost, but also on safety. Or am I seeing this right?
Yes, if you look at safety, always is number one concerns where if you have something that is mechanically moving or moving at a high speeds or constantly heating up,
something where energy is condensed, right, in form of kinetic energy, chemical, thermal, whatever. If there's condensed energy, you have to be careful.
Not to forget conventional cars, the recall rate is also pretty high. They also have a lot of safety concerns. If you look in the past history, there's a very good statistic saying that 2-3% recall per year is normal for conventional cars. But when it comes to a spotlight like EV, and if there's one brand that has been recalled, everybody is concerned.
Yes.
And safety ties to brand. So if you have a safety and then you have a high recall rate, that means it's super damage to your brand, right?
Your brand just sucks.
Then now if you think of it, people, how to make the judgments of calling back those unsafe products in the markets. Some of them have to make clear decisions. Should I call all the batches, or I call a particular range of batch, or a specific batch? So this kind of decisions cannot base on feeling. You must base on real facts. Where digital data is really helping you, right? If you really have the manufacturing collected all this data in your hand, then you can make faster judgment. And also even support the supply chain, downstream customers or upstream another set of users. How these are going to really play is really finally the transparency. Where should I only get recall of my car over a letter. There's no push notifications. We are in the age of smartphone.
It should pop up on your head-up display, right?
Correct. It should just pop up in front of you and say,
it should not pop up because
fundamentally we don't want it to pop up.
Exactly.
But if there's something not safe, we want it to pop up so that we are not trapped in the fear that out of nowhere I'm driving to the Black Forest alone. Then the message pop up at the time when I'm in the middle of the forest, where nobody can help me, right?
That's true. It has to be done at the right point in time. But talking about time, I think from a managerial point of view from the company's perspective, it's also important because if you look at it holistically, the sooner you can act, the more damage you can save. And coming back to the transparency point where you have the digital continuity, everything is connected, you can identify issues really quick. And then also make the right managerial decisions to act, right? And to save costs. Because I think for those cases, every minute that is unacted is like directly related to a cost increase.
Correct. So in medical device industry, it's very high cautious about quality and safety. I have customers who make special medical device. The quality manager, middle of the night, get a call from the system saying, "Hey, do you want to release this lot? We found a problem or not." Then this is not a good moment to just based on feeling or just decide it quickly. You have to go and investigate, and make sure that you proper do it. Imagine that if that device is going to implant into your body, and now you have to recall. So are you going to do another second operations to achieve that?
That becomes even more urgent and critical.
Correct.
Yeah.
If you look at EVs, EV is still not really like embedded to our body or direct impacting us. But the other side of the impact, safety is.
But nevertheless, they are.
It could hurt you. It could really.
It could. Exactly.
If the radar system is not responding and you drive it, the autonomous driving, okay.
There's an issue. Yeah. I think that highlights the fact really well. And just coming back to your the example, like doing all this on paper, like in the manufacturing, writing all the and then going back to loads of paperwork and fiddling through, like, okay, where was the parameter that we're looking for because we found an issue and our manufacturing is off since then. No, you don't do that anymore.
That's not the way for our futures engineers to work in that life. Yeah. So maybe 50 years ago, yes, but nowadays we are talking about high volume tools, especially gigafactories. We are talking about millions of cells that can produce in a day, and then in a month there's so many cars that could just.
So every second that runs, many cells are produced, and the second that you don't act, when you see a fault in the manufacturing or in the supply or whatever, is lost money, is wasted material, and it also has a point on sustainability, right? You're just wasting material.
Yeah, if you look at it, it's in the entire battery manufacturing, the last piece of it, the aging test, took most of the manufacturing costs because they have to charge again.
Takes time.
It's not magically, but these are the time well spent because it gives you the sense of how the process are doing in the manufacturing, because that's the end of the line where the eyes is, where you can really judge, did you do a good batches coming out? Your supply chain is okay. You don't have something that is really out of qualities from your suppliers. And that point of time is where all this end of test, aging test that you are doing, there's a lot of data. At the end, if these data are stored forever, which the car can be running on the road 20 years, in another few more years, the car life is longer than our own expected. It could be conventionally. We have cars that is only combustion engine is 15 years. But if you look at EV, and if you have a good battery or interchangeable battery, the car could be on the road for 25 years, or 30 years.
And I also have discussions would go, and it's difficult to imagine that at the moment. But I see it also that the lifetime of a car will be extended quite significantly from the baseline that we see currently.
Yeah, if you in the field of electronic and electrical engineering, you know that DC it's consume lesser powers and the lifespan is longer. That's why we instead of living in the analog world, we are now in the digital world. Whether you have a LED instead of a luminance,
for the lighting, the ceiling.
For example, those LED has longer lifespans now. Even manufacturer comes to us. Some of our factories is saying, "Hey, we are having 10 years warranty." So, in order to really understood, the risk of giving. To commit that 10 years, you also need data. You need to collect from your manufacturing to know that, okay, my process is good, it's consistent. Then
you can be certain that you can guarantee.
You can guarantee already,
and you won't ruin your company by making those guarantees to your customers.
It's not just like I say, it's say it's easy, but make sure that it's consistent and really deliver that commitments of warranties that you have in the product. So EVs definitely, I see that in long runs, we will have much better electronics, and then that consume lesser electrics, and then you have more electrics that can drive better motors, direct DC motors, all these. Sooner or later, DC, the live DC motors, for example.
For EVs?
For EVs, it could be.
It could be.
Okay. If the technology itself are evolving, we always evolve. Instead of AC motors, we also look at DC. There's many other choices.
There are many different ones, but I'm curious on that.
So if it's the important thing is to solve the equations to have high torques deliverable from the rotation systems, right? So whether you continue to have a high power, or you find a ways to optimize to use low power devices. You want your phone to be, let's say, no need to charge for 3 days. Then they have to optimize the design. They have to string the design. They have to find, let's say, a smart ways between software and the hardware work together. Then you get a better user experience of no need to charge every day. Right?
Yeah, of course. And then, as we said, like that's again in the usage phase of the product then, but. And maybe as a last point on the outlook end, so we have the manufacturing, we have the use, and then at some point, even though the use may be extended quite significantly in the future, I think that is also what the research is showing, that batteries are not just decreasing in cost, but increasing in performance and lifetime.
Yes.
And with it, the EV, because the battery is really the limiting component right now. So I think the other manufacturing end, so the demanufacturing, so to speak, I mean remanufacturing in that case, or leading to recycling, would then be also a future topic that you would look into on providing transparency links, so to speak, to come back to our key topic here, meaning a continuity of information, so that you kind of close the loop, right?
Or carry on the information, let's say, to the recycling plant.
Yeah,
so
you
that
carry
they
on
know,
that information.
Yeah, if you can carry on that information, like after 20 years, then it comes back to recycles. You know that what happens to the actual usage of the product.
Yeah.
Then you will already could decide, how you want to recycle the materials out. Recycle also need to make a good decisions, like if it's more than 2 million charge cycles, there's nothing to recycle anymore.
So we have a kind of an information chain there.
Yeah.
Besides the actual physical supply chain that has to be established to provide this continuity.
Correct. The industry, there's no one company can do it end to end now, right? So and there's a lot of big players around as well. So as some of the new players to come into EV or come into a battery manufacturing, it's also need to collaboration. So that's why you can see now a lot of gigafactories that coming up is working together with the OEM. Working directly
there are
with
partnerships.
A lot of
That's
partnerships
true.
because
That's true.
they are the want to secure the demand. They are also the one that want to drive the industry to adopt to EV, right? So they must work with someone that is able to, let's say, give them the capacities. But at the end, they still, who is going to do the recycling? Because EV is still new, right? It's just like probably the last 10 years. You still have a lot of, let's say, EV are brand new, not recycled yet.
Yeah.
But coming to the end, how to carry this information to make a good decision, what to recycle, how to recycle, what is the potential of the recycling result.
Can it go back into
Can it
a
go
grade
back to
A cell, or do we need to downgrade it?
Yeah, correct.
Understand,
Or downgrade it to another usage.
That's what I mean. Like, is it applicable for a mobile application still, or do we can only use it for some stationary storage where energy density or volumetric density doesn't matter that much? That may be something that you can provide transparency on.
Correct. Exactly.
Cool. Yeah, looking forward to the development there, and I hope we'll see more transparency and more collaboration, as you pointed out, in the future, right?
Yeah, between the manufacturers together with software company like us, able to digitize the entire operations, then go to the next step, getting let's say all the supply chain connected, and that will be a steps looking forwards to build. At least it will take 10 to 20 years. So I did this for semiconductors. It took us 15 years. When we start talk about incoming supply digitizations, people are asking me 15 years ago, why should we do that? Our supplier won't work with us. But today, I work with so many semiconductor companies. They already have all this information about raw materials coming in. Information before even the physical delivery. So they have the information on hand. They even can prep the factories to say, when this material arrives, can I directly go production, start the productions, So this will be a cool directions for EV manufacturing, because finally you look at the demand, let's say how many EV cars that you want, then go back, if you can say how many battery pack I need to produce today, and go back and say the supplier need to ramp up now, and you provide you the materials to go forward. This will be a revolution change to how we create and address the demand,
So I think then it's kind of time to do a little shout out to industry, get together and start talking. Right?
And
start
create the synergy
and
to work together. Because if you want to sustainable, you need to have a complete, let's say, supply chain which is harmonized. Then you can really say that it's sustainable, because we are doing something that not wasted. And all the information, energy they put into the supply chain are well, let's say, used on the data they collected, the investment to buy the best equipment to measure. All this can be share among the entire supply chain. You know, your supplier already measure with the best equipment. Okay, you can save your incoming check.
Yeah.
Now you trust your supplier. Go next, when you produce, you also have the best, let's say, aging test in the battery manufacturing. The OEM don't need to do the test again. They can straight away take their batches, produce the e-mobilities or the vehicle itself and get into the markets, right? So we all save a lot and optimize the whole cycle times here.
And maybe the idiom holds to build on the feet of giants, kind of, to learn from another step by step.
Yes.
Right, and doing that by means of data and knowledge out of that data.
I would say it's tough when manufacturers are protective towards what they have, as in terms of data, not to share. It's quite nature. You know, when I first met someone, I would not share everything. It's a nature, right, of how humans behave. But if you really open up their hearts and really do, let's say, real business in the way benefiting for both sides, I think sharing those data will become a norm.
And I think we can both, out of both our individual positions, drive supporting that development. Thank you, Bryan. It was a really cool conversation. Really appreciate that you came to eLab today to have that talk with me, and you're always invited.
Looking forward to the next podcast we do again.
We'll do.
Yes,
okay,
definitely.
bye.
Bye.